dots are no mere stars, but galaxies and groups of galaxies. Radio telescopes map the cosmos. They've discovered quasars and their elderly relatives, radio galaxies. They trace neutron stars, the relics of supernovas, and clouds of hot gas that emit no visible light. Teams of dishes work in unison. By linking them electronically, astronomers create a giant receiver. Each dish sees from a slightly different perspective. Together, they synthesize a sharper image. This picture is such a composite. It shows red billows of gas surrounding a galaxy. An ordinary telescope would see just the galaxy.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
Centaurus A, a galaxy in turmoil, a photograph through a powerful optical telescope. Map Centaurus A with a radio telescope and we see the turmoil. Two huge lobes of radiation stretch out from the galactic center. They emit intense radio signals. Here, another double radio source, the unusual galaxy Cygnus A. The optical image completely misses the action. And here, a galaxy traveling at speed through the intergalactic medium. High-energy particles in jets. By modeling their behavior on a supercomputer, astronomers are learning about a giant galaxy in the constellation of Virgo. It's Virgo A, one of the most powerful radio sources in the sky. Radio reveals a jet of escaping radiation. Imaged over 10 years at the VLA in New Mexico, the jet is a sign of feverish activity at the heart of the galaxy. By analyzing the jet section by section, observers time-lapsed its phenomenal development. The galaxy is ejecting material at an incredible rate, apparently faster than the speed of light. But that's impossible, an illusion caused by the angle at which we observe the jet. Radio images have been augmented by the Hubble Space Telescope. Here, Hubble's optical close-up of the jet. Computer animation shows what's happening. The jet blasts from the core of the galaxy. It's one of two, produced as a spiraling disk of matter, is sucked into a massive black hole. Similar jets shoot from black holes in quasars, the most intense concentrations of energy anywhere. Is there a black hole at the heart of our own galaxy? No one really knows, but this radio image of our galactic center suggests it's possible. The S shape on the right is the clue. Closer in, the S hints at material swirling around an invisible core. Closer still, but there's no sign of radiation jets. Scientists are puzzled. Perhaps our black hole is between meals, waiting for the next stellar dish to wander by.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
The Hubble Space Telescope has triple vision. It works in the visible range, plus ultraviolet and infrared. In the visible band, this is the smoggy face of Titan, the largest moon of Saturn. But here in infrared, Hubble cuts through the clouds to reveal what may be continents and oceans. Infrared radiation can be detected from Earth. One of the best places is atop Mauna Kea, an extinct volcano in Hawaii. High above the clouds, the air is clear and dry, excellent for observation. But there's an even better place to catch infrared. The South Pole. Believe it or not, it's drier here than on Mauna Kea. This detector at the Scott Amundsen base is the clearest earthly eye in infrared. Infrared astronomy has come of age during the last decade. Its wavelengths are so close to visible light that the images seem optical. Nonetheless, they reveal aspects of the Milky Way that once went undetected. One of the most celebrated vistas of our galaxy, the Orion Nebula, but in the visible band, most of its stars are obscured. Infrared lifts the dusty curtain. There they are, scores of stars, bright and young. Optical astronomers aren't sure what's happening in the heart of the nebula. Infrared reveals a catastrophe. A young star has blown itself to pieces just as it was starting to shine. Still in Orion, and enveloped by dust in the bowl of the nebula, lurk the trapezium stars. In infrared, the dust settles and the stars shine through. In an optical telescope, an astronomer's disk blocks the light of a star. It reveals a halo. Using this method, infrared detects a disk of dust surrounding Beta Pictoris, one of the nearest stars to Earth.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
Earth's atmosphere absorbs extreme ultraviolet, so we use spacecraft to catch it. This satellite, the Extreme Ultraviolet Explorer, probes our galactic neighborhood. The Explorer has discovered we live in a bubble, a gigantic envelope of clear space. The bubble is formed of cool, thin gas extending several hundred light years around the solar system. But why? What blew the bubble? The Explorer has found some clues. Methodically, it scanned the cosmos segment by segment, the task to log every source of ultraviolet radiation. While assembling these swaths of space, the Explorer made the most exciting observations close to home. Near the stars of the Pleiades, the Seven Sisters, it discovered this black patch, a bubble of gas. Indeed, it found several bubbles in our vicinity. One theory says that they're holes blasted by the death of gigantic stars, the explosion of supernovas. Along the spectrum, in the short waves of gamma radiation, the dot at the center is Geminga, the remains of a huge star that exploded 300,000 years ago and blew the bubble that surrounds the solar system. All that's left of Geminga is a neutron star with an intense magnetic field. Geminga's explosion was a regular supernova, but if a supergiant explodes, the result can be a black hole. Everything, including the neutron star, falls in on itself. Nothing remains. Sensing such sources of radiation is the job of the Compton Gamma Ray Observatory. It's logged hundreds of black holes and neutron stars, but it's also picking up shorter random bursts of gamma radiation. They come from every direction, and no one knows what they are. They're far outnumbered by long-term signals from the likes of black holes. One possibility is that short bursts occur when neutron stars collide. Compton is building an exotic map of the gamma ray sources all around us. La Palma in the Canary Islands. Here, at almost 8,000 feet, these aren't beehives, but detectors looking for the effects of cosmic radiation hitting Earth's atmosphere. And this fly's eye is picking up flashes of light from high-energy gamma rays. These emissions reach us from the farthest corners of the galaxy and beyond. And they're a mystery. We don't know how they began their journey or when. One day, perhaps La Palma will help solve the riddle. COBE, the Cosmic Background Explorer, was launched to look back at the beginning of the universe. Through clouds of dust and gas, it set out to find the coolest radiation in the cosmos, radiation that's been around since before the galaxies. It charted a remarkable map of the early universe. Here it is, 500,000 years after the Big Bang. From more than 10 billion years ago, COBE's data seems to confirm how things began. Light and energy became matter. Under the influence of gravity, subatomic particles clumped together. From radiation and dust, galaxies of stars evolved. One was the Milky Way. Within it, 5 billion years ago, our sun and the planets were born. Today, we peer back through the instruments of new astronomy, and we're still asking the old questions. Those answers must come from the invisible cosmos. the Milky Way. So ghostly, it's invisible in moonlight. Only after the moon has set does the Milky Way appear. Only in the darkest and clearest skies do we glimpse its galactic splendors. This is the Milky Way. In ancient Greece, Aristotle thought it was a band of fire fueled by the vapors of Earth. Democritus said it was a great collection of stars, so distant they merged with one another. Democritus was right. The Milky Way is a galaxy, an island universe, a family of 200 billion stars. We belong to that family. Our sun is one of these stars, a single point of light in a swarm of energy and brilliance. But because we're part of the galaxy, we don't see it as a whole. For an overall impression, we must seek a look-alike among the billions of galaxies that populate the universe. Astronomers call this NGC 891, a galaxy over 40 million light-years away. It's a dead ringer for the Milky Way. In this perspective, we're looking sideways at its vast disk of stars. This satellite picture of the Milky Way could be its twin. It's our partial view of our galaxy. If we could escape from the plane of our galactic disk, we could see the Milky Way in all its splendor. The ingredients of the Milky Way are stars and restless clouds of dust and gas. They're molded by gigantic forces, the push and pull of gravity, magnetism, and nuclear fusion. These are the true colors of our galaxy, nature in the raw. With radio telescopes, astronomers penetrate the clouds of cosmic debris that obscure so much of the Milky Way. Toward the galactic center, in the false colors of radio waves, they spotted vast clouds of hydrogen gas. Such information, along with infrared images like this, helps scientists map the galaxy. And by looking at other galaxies, they're learning about structure. Some 25 million light-years away, this is M83, like the Milky Way, a spiral. On a computer, we see the stars of the Milky Way orbiting the galactic center. Clusters of ancient stars hover outside the disk like bees around a flower. In a blue arm of the galaxy, 2/3 of the way from the center, is our star, the sun. Here in these galactic suburbs, stars begin their lives. This bubble of hydrogen in a neighboring arm is such a birthplace. Within the bubble, matter is squeezing ever denser. Gravity increases, temperatures soar, nuclear fusion begins, and stars are born. a photograph of that stellar nursery. The oldest stars are those groups hovering outside the central disk. They're called globular clusters, each comprising up to 1 million stars. The most elderly clusters are 12 billion years old, nearly 3 times the age of the Sun. One of them is a monster, almost a galaxy itself, a retirement home to 6 million stars. In the orange glow are more ancient stars, billions of them. They form a great bulge at the heart of the Milky Way. Farther out, younger stars appear blue. From Earth, we're looking along the plane of the galactic disk toward the bulge of orange stars at the center. On Earth, the best views are in winter from the southern hemisphere. This remarkable time-lapse tracks the Milky Way over one night. Like the course of the sun during the day, it's not the Milky Way that's moving, it's our planet turning on its axis. From the top of the picture, the bright center of the galaxy moves into the frame. A wispy galactic arm extends to the right. The Milky Way is so big that for light to travel from one side to the other takes 100,000 years.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
For 20 years, this man has had the sharpest focus on our galaxy. David Malin, photographic scientist at the Anglo-Australian Observatory in New South Wales. Malin's lenses are gigantic telescopes. This is his wide angle. It's the UK Schmidt telescope, with an aperture nearly 4 feet wide, focused on the galaxy. The Schmidt has no eyepiece. It's designed for electronic and photographic observation. Instead of film, the camera is loaded with a plate of specially sensitized glass, 14 inches square. An instrument nearby does the close-ups. With a mirror almost 13 feet wide, this is one of the biggest telescopes in the southern hemisphere, the 3.9-meter Anglo-Australian, perched above the outback. Through clear, unpolluted skies, Malin pursues his craft, basic photography penetrating the depths of the galaxy. The telescope is so big, Malin can ride in its mechanism.
Right, see you in 3 hours.
Okay, Kevin, next object, please. Okay, Dave, here we go.
In the prime focus cage, like an astronaut in a module, Malin takes off for a night in the stars. One picture takes hours. It's a composite, 3 successive exposures in green, red, and blue. As Malin loads the first plate, his vigil begins. Tonight's exposure is short, only 3 hours. But if the object is faint, it could take 3 exposures over 3 nights, each lasting 8 hours. Malin works with his back to the stars. Their light is collected in a huge mirror beneath his cage. It reflects to a focal point in the cage and in the camera. The telescope tracks the target by compensating exactly for the spin of the Earth. Back in the darkroom, Malin matches the 3 exposures. Only by returning to basic technique can he squeeze the maximum detail from each exposure. The ingenious composition he's building produces an image packed with information. It's as though we were viewing the galaxy with eyes 100 times more sensitive to color and light. The naked eye sees the galaxy in black and white. Malin's composites unveil natural color. But they're not just pretty pictures. They're a key to discovery. They reveal the nature and relationship of stars, the evolution of the Milky Way.
There's a structure, a crosshair structure inside the telescope, and light scatters around that.
Malin is astronomy's most celebrated photographer.
Thanks for coming.
His books and lectures have a double appeal. Amateur astronomers who've looked at the sky in awe and tried to photograph it want to learn to do it better. For professionals, often preoccupied with specifics, he sets their work in context.
This is the kind of coloration you would see. These are not artificial colors. These are the real colors of nature.
David Malin, the man who colors stars. Photographs of the galaxy reveal only part of the story. To peer beyond optical images, astronomers employ a battery of telescopes and spacecraft. They explore in different wavelengths. They detect cold clouds of dust and gas and regions of stellar birth. If any planets orbit nearby stars, these space probes will surely find them. In wavelengths like ultraviolet and infrared, impossible optically, these are views along the plane of the galaxy, looking toward the nucleus of our system. From above, so to speak, this is the view we never get. The great spiral of the Milky Way, a picture map compiled from several wavelengths. Here, in the sector we see from Earth, we begin an odyssey, a journey through David Malin's camera. His photograph of the Eagle Nebula, a cloud of red hydrogen where stars are born, so distant that their light takes 6,000 years to reach us. Another birthplace, the hub of the Trifid Nebula, hydrogen gas and black lanes of dust. In this Malin picture, we pull back from dark peripheral clouds to reveal the brilliance of the Trifid Nebula, whose light they reflect. These stars have blown away their clouds. They're the jewel box, like gems on black cloth. By contrast, there's cloud everywhere. Nebula means cloud. At the same distance, 8,000 light-years, loops of gas are created by stellar winds blowing from the depths of another star-forming region. Back to the picture map and to a cloud with a tiny pulsing heart. It's the Crab Nebula, the debris of a supernova. Within it spins a pulsar just 10 miles wide. In animation here, the relic of a gigantic star that exploded nearly 1,000 years ago.
Wonders of the Universe will continue on TLC. Wonders of the Universe continues on TLC.
The Rosette Nebula and the Gleam of Youth. At the center, 4,500 light-years away, a nest of bright new stars. But as we focus nearer home, new stars are not to be confused with novas and supernovas. This is a nova in the making. The supergravity of a small, dense star is pulling matter from its companion. In a buildup that happens again and again, there's suddenly a moment of indigestion and then a bang. To the ancients, it was a new star, a nova. And here, the remnants of a supernova. Again, nothing to do with birth. This is the Cygnus loop, the entrails of an enormous star that blew itself to pieces 60,000 years ago. But in death, there is renewal. Such gigantic explosions are thought to trigger the formation of other stars, stars like our sun. Supernovas seed the galaxy. Here, hydrogen gas glows red, excited by radiation from hot young stars. Orion heaves with stellar gestation. Below, as a plume of black dust rises in the foreground, another Malin masterpiece, his famous Horsehead Nebula. Science as art. But this